So today, I will present our group project. So my team members is me myself, Muhammad Darus Daniel bin Muhammad Fazli, and then Nur Asriza binti Osman and Muhammad Faris bin Azni. So for our group project, first of all, we need to create the deployment slots or to create a web app, which is first we need to sign into the Azure portal. And because of I didn't have the because of we could not uh, subscribe to the Azure portal, so we use Muhammad Hadif bin Roslan Azure subscription. So we have do it, and we will just present it through this report. So first, we need to sign in to the Azure portal, and on the Azure portal menu or from the home page, we need to select a create resource. After we select the create resource, we need to search for the web app, to create the web app. After we click on the create, we'll on the basic tabs. On the basic tabs, we need to put our resource group, which is I put here is this. And then for we need to put the Azure subscription one, and then for the resource group, make the new resource group, which is this. Then publish in the runtime stack, we need to put it to ASP.NET version 4.8, and the operating system is Windows, and our region is East Asia. After that, for the pricing plans, we need to take the standard S1, and the Windows plan is there is new Windows plan for the pricing plans. And then we need to review and create the web app. After that, in the deployment tab, which is here, this is the deployment tab. In the deployment tab, there is we need to, in the authentication settings, we need to enable the authentication setting. So just for the basic authentication, we just select enable. After that, on the monitor and secure tab, we need, for the application inside, we just click no. And then we need to select and review plus review and create and select create this. From review and create, we need to create the web app. So when the deployment successfully completes, we need to go to the resources, and the app service panel will appear, this is our web service panel. This is what we just did just now. So as you can see, the web app name is this, and the resource group also this, and the location is East Asia. The subscription is Azure subscription 1, and they will give us the default domain, which is the domain for us to watch the web app. Next, after that, we need to configure the Git deployment, which is on the web apps service page in the left menu under deployment. We need to select deployment center. In the deployment center, there is a settings tab, which is this. And for source, we need to select the local Git. After that, we need to go to the FTPS credential tabs. Under user scope, we need to enter the username and password and then save. As you can see here, what we did is under the user scope, I put the username Zeis, Zeis, and the password. The password need to be more than 10 alphabet, and then it need to have one upper letter, one uh, numbers, and also symbols. So as you can see, for the password, I make it Gajah Terbang at 123. After that, we need to configure the Git client and clone the web app source code. As for this, first you need to open the Azure Cloud Shell in the top bar. So in the top toolbar, there is three three dots, which is when you click on it, it will show the Azure Cloud Shell, and on the bash, and on it, we need to set the configure values, which is first we need to type this git config dash global user name, which is this, and then git config dash global user email, which is muhammadhadif70@gmail.com. I'm using this because I'm using his subscription. After that, we need to create a folder for the source code, which is the folder, we will name it demo app. After that, we need to go into the demo app. So cd demo app. After that, we need to clone the source for the web to the folder. So where we should get the so we just type git clone https github.com azure dash samples app service web.net get started.git. So we just use the URL that have been given. After that, we need to open the in the demo app. After we put the URL, so we need to go into it. So cd app dash service dash web.net dash get started. After that, after clone the source for the web to the folder, we need to configure a git remote to deploy the app to production, which is first we need to go to the web app and select overview. The default domain URL and git clone URL will be displayed in the overview of your web app, which is just now I have shown you that we have the default domain, the app service, Windows, git deployment, and git clone URL. So this is my git clone URL. And in the Cloud Shell, we need to run the following command to configure the Git remote with a name production. So first, what we need to do is on the Cloud Shell, we need to type git remote add production and our git clone URL just now. After that, for us to deploy the web app to the production slot, we need to run the following command, which is git push production main master. So when we press the enter, it will need for us to put the password. So I put the password, which is Gajah Terbang at 123, and then it will deploy. After that, we need to go back to the web apps overview page and then click on the default your domain URL to check if the website received the content. So here is the this dash araba. So this is our URL from here, from the from the default domain. So we need to check if it show the ASP.NET, the web app. So that's all from me. Next, I will pass to Nur Asrizal bin Osman.
Okay, my name is Noah Riza, and my my role is to create a new staging slot for the web apps. For the web app, you create we create only one slot, the production slot. We deploy the source code to this slot. Next, we will create the deployment slot where we can stage a new version of the web app. So, so to do this, we select the web app and go to the deployment in the left menu. Select development slot. The development slot panel will appear from the top menu bar. Select a slot and add a slot panel. So for the next, enter staging as the name and accept the default of the close setting. From then, select add. In the name field, enter staging, accept the default of for the close setting from, and then select add. After the development slot in successfully create, select close for this one. So for the next task, set up Git development for the staging slot on the Azure portal menu or from the home page. Select all resource in the list of all resources. You can filter on resources group MS learn slot. You will see two app entire enterprise development slot are represented as a separate app in the portal. Select the any Select the entry representing the staging slot to go in overview pane. On the overview pane in the menu under development, select development setup. On the setting tab for source, select local git, select save. On the resulting deployment center pane, select the local git slash https credential tab. Under user scope, enter the new username and password of your choice, and from the top of menu, select save. Make a note and password for the letter like this one. We use username this and password is this one. Gadget Roban. Next, we set up Git to deploy the app to staging slot. To use the Git client to deploy source code to the new slot and extra remote to the Git configuration. Follow step. First step, we in the Azure portal on the staging web app overview page in the essential section, select the copy to clipboard icon for the Git clone URL. Note that URL contain your development username. So this one my essential. So we create this one, and now we go to CloudShare. To add the remote for the Zegistron, run the following command in the CloudShare. Replace git clone to our URI from the previous step. So we go to cd demo app, cd app service web.net get start. So we using git remote add staging on the our web page to clone this one. And also next step, we modify the app source code and deploy the apps onto the staging slot. So next, we make a small change to the web app and use Git to deploy the new version on the to the staging slot in CloudShare. Run the command. So we reuse code space dot. So like this, and you will go to this choose the file where we want to demo app and choose the ESP um, for to view home select the index dot hash the CSHTML. So we changing from ASP.NET to replace this code, we change to the web app version 2.0. So when we change the press the Control S and then Control Q for the close the um, editor. So now we 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 need to add the new staging. So git add git commit dash m a new version of the web app. So the way it will be running like this, and we'll now to check the browse of the staging slot. Now we can view the new version of the web app by browsing the staging development slot URL in the Azure portal. Go to the overview page for the staging slot. In the top menu, select browse. The new version of the web app appear in the web browser tab. At this point, the staging slot has the new version of the code, and we run tests on it. That production slot has the previous web app version, and user cannot see our new plot. So this one, our web version 2.0. So now we need to deploy a web app by using development slot. Go to configuration and slot setting. Before we deploy version of 2 web app, configure a slot setting, and then we setting our configure here for one affect our demo app. To purpose of the exercise is just to see how the configuration work when we swap the slot. So we edit an environment variable, and so now we from our resources in view in the Azure portal, we navigate the overview page of the production slot of the web app. In this my web app, navigate the configuration page, select the new application, and add new setting with the environment name and value of production like this, and we apply this one. So for next, we check the deployment setting box to make this slot setting and another setting called app version, and the enter value ones. So we like this and click the apply. So now we checking our version that has been our setting that has been deployed. So we go to next. First, we repeat back step for staging slot, but use the value, the following value like this one. So we using environment name value staging deployment slot, yes. Version 2 number. So we add the application setting again like this one, up version. So now we checking the staging state for this staging environment variable. So we want to swap the slot. Now we test version 2 of the app in the staging slot. We can deploy it by swap the slot followed by following steps. To make sure we configuring the production slot, select our resources, then select the production slot of the web app. Make sure the about the swap, the staging and production slot. Notice how the swap will affect setting. The value of a version setting will be exchanged between the slot, but the value of the environment slot setting won't be swapped. Select swap. So we will be display this one. So we choose our what one we choose what and start the swap. So for the next, when the swap is complete, go to overview the slot web app that has been appear on the new browser tab. Notice that version now is now in production. In the production. So we close the browser tab. Now configure auto swap for the staging slot. Suppose that that now that we're using deployment slot, we want to enable the continuous deployment. We do this by auto swap feature for our web app in the system that use auto swap. When we deploy the new code staging, Azure will will automatically warm it up and deploy the production by swapping the staging production slot. To configure auto swap, following this step, go to configuration and navigate to the general setting. So set auto swap to enable on in the swap deployment slot list, select production and then select save like this one. We select the auto swap and click the save for this one. Now we deploy the new code and auto swap into production. We also modify the code that create a version 3 of the web app that we deploy it to the staging slot and see the auto swap in action. On the right side of the cloud share, restart the editor if not ready, if not running. So we use this command cd demo app and app service web.net get start. So we edit the code here. So in the editor code, file, view, and select home, and then select in the HTML like this one. Now locate the following code of version of version 2. Now we change to the web version 3.0. So now we use Control F and Control Q to quit this. For the cloud and net in the cloud share, enter the following command to enter your deployment password when it prompt. So we use cd app service web.net get start. So we also use git commit -m third version of the app. So it will be running. So wait for the deployment to finish, and near the you will see the message indicated that deploy has request to auto swap to the production like this one. In the Azure portal, navigate to the overview page for the production slot web and select browse the version of the app appear on the new browser tab. So like this one, it will be show the version app web app version 2.0. So we'll roll back to the new version. Supposed to deploy the version 3 of the an aspect problem to quick solve reform in we roll back to the previous version of the site by swapping the slot gain. So we want to for the version 3 to version web 2.0. So go to the setting page of the production slot web app, swap the staging production slot, and we will change swap this one. So now when we test on our browser, it will be changed back to version 2.0. So now my task has been done, so I will proceed to my friend. So
Assalamualaikum warahmatullahi. My name is Muhammad Faris, and today I will present on how to scale a web app manually. So we in this group project, lastly we will create an app service plan and deploy a web app using this plan. we will monitor the performance of the web app under load. We will then scale out the app and verify that its performance has improved as a result. So this exercise use a simple web app that implements a web API. We also run a client app that simulates several users, issuing posts and get operations simultaneously. This app provides the workload that is used to test the performance of the web app before and after the scaling. So first, we have to create an app service plan and web app. So the step is first to sign into the our Azure portal, and then click on the menu from the home page and then select create a resource. So from the resource list, we have to find the search bar and then select try to search a web app or find a web app in the create a resource. Then create web app pane will appear after you search a web app. And then to create a web app, we have to enter this following, which is for the subscription, we have to select the Azure subscription that we would like to use for this exercise. And then for the resource group, we have to create a new resource group called MS-Learn slash scale. And then for the name, we have entered the name hotel reservation system that so that we can remember for the letter in this exercise. And then we have to choose the code public instead of container. And then for the runtime stack, we have to choose the .NET 8 LTS. And then operating system is Windows. And then after all of this already selected, then we can create the web app. After create the web app, we have to deploy the web app so to deploy the web app in the Microsoft Azure menu bar, select the Cloud Shell icon to open the Cloud Shell and run the following command to download the code for the hotel reservation system. The code is gclone https github.com/Microsoft docs and/MS-Learn hotel reservation system .git. And after that, we have to wait around 10 seconds to download. After download succeed, go to the Learn Hotel reservation system to and then build the apps for the hotel system. There are two apps, a web app that implements the app API for the system and a client app that will be used to load the web app. So first we have to change the directory to MS-Learn hotel reservation system, such as here, and then we have to build the change the directory. Then we have to enter this command .NET build. Then it will show the 0 error and time elapsed, which is 31 seconds. And then we have to prepare the hotel reservation system web app for publishing. Next, to do that, we have to cd again to hotel reservation system, and then use the .NET publish -o website command to implement this. And then go to the website folder, which contains the published files. Zip the files and deploy them to the web app that you created in the previous task we did just now. And we use the following code to the notepad and replace our your app web name to our app name, which is hotel reservation system, with the name of our app. Then paste the edited code block into the Cloud Shell and run it. So to do that, we have change directory to website and a zip website, and then can wait around. Then we have to enter the exact web app deployment source. And then for check if it's already here, then we have to go to our local browsing such as Chrome, and then enter the HTTP our app name, which is hotel reservation system .azure websites .net/API /reservation /1. So it will appear this one, which is reservation ID, customer ID, hotel ID, and check-in. What time is check-in and check-out? Next is to monitor the performance of the web app before scaling out. So return the cloud shell and go to the MS Learn, change directory to the MS Learn hotel reservation system, and then cd and then use the code apps.config to enter the file folder to edit the command, which is here. And then we have to uncomment the line that specifies the reservation service, URL, and replace the value of your website name with the name of our website, which is hotel reservation system. And then after we fix and edit this, we have to save, which is use the Control S and Control Q. And then again, we have to rebuild the test client app with the new configuration using this build, which is using this command, which is .NET build. Next, to edit the hotel reservation system test client file to use the correct framework. So first we have to use this command, which is code, and this file to enter the folder, and then edit this. Edit the Net Core App 2.1 to Net 8.0, and then again we have to Control S and Control Q to save and close the editor. Then run the client app. It's here. It shows that client clicking reservation, and in the Azure portal, let's go to the resource to open your web app, and in menu, scroll down to monitoring and select metrics. On menu bar of your web app, select the local time, last 30 minutes, and select apply. And then in the menu under the chart title, add the following metrics to the chart. First, select add metrics, CPU time, and select the sum aggregation. And then select add metric, HTTP server errors, and select the sum aggregation. And then select add metric HTTP 4SS, select the sum aggregation. And then select add metric average response time, and then select the average aggregation. In the menu, under the chart title, select pin to dashboard and then select pin as this one. After that, allow the system to run for 5 minutes to stabilize, and then note the CPU time, number of HTTP 4SS errors, and the average response time. You should see a significant number of HTTP 4SS errors, and the average response time is several seconds, as we can see here. For CPU time, it shows that the blue line here, and for the HTTP errors, it's the pink line, and the HTTP 4SS sum is the green line. Next, we have to leave the client app running while you perform the next task, which is we have to scale out the web app and verify the performance improvement. So in the Azure portal, to do that, select your web app name, which is hotel reservation system. In the menu, you have to find the setting and then select scale out. which is for the app service plan. Scale up and app service plan. And then on configure app, set the instant count to 5. So we have to slide the speed just to it shows here is 5. And then we have to click the save button. And then again, run the app for another 5 minutes. Let's go to the chart that shows the metrics for the app on the dashboard in the Azure portal. You should see that the CPU time has increased dramatically because there's now 5 response time, which is this one, the blue one. Because there has now 5 response times should have dropped, and the number of HTTP 4SS errors should also have decreased, which is the green line. The following chart shows a typical set of result. The point at which scale out occurs is noted. Then return to the Cloud Shell, push enter button to stop the button.